versus if and only if when one contains A, B, the other will have what? What? PA. So this is basically our rule for inverse relations. If one of them has the point A, B, the other one has to have BA. So if we had 3, 2, what does the other one have to have? 2, 3. So that would mean these two are inverses. So this is when you're dealing with relations. It's very simple. You just got to figure the point. Maybe something a bit more complicated, but we're more interested in inverse functions. Now, notation for inverse functions. Is we use this. So this symbol means the inverse of f, or inverse of the function f. Now, we want to say, how do we tell if something has an inverse or not? To tell if function has an inverse function. Use a simple rule. So, what was our first rule saying? How do you tell if a function? How do you tell if a relation is a function? What's the rule? Vertical line test. Remember that? If it's a function, it passes the vertical line test, which means what? Each x has exactly one y, right? Or a vertical line will only touch it once. Now, to tell if a function has a inverse function, we use something called the HLT. What do you think that would be? Horizontal line test. So, for example, let's do a graph here. Is that a function? Yeah, we can tell that because it passes the vertical line test, right? Does it pass the horizontal line test? Which means that it also has an inverse function, or there's an inverse to this. What if we did a quadratic? Is that a function? Yes, because it passes the vertical line test. Good. Now, does it have an inverse function? No, because it does not pass the horizontal line test. If you drew a horizontal line across here, touches two spots. So we talked about the vertical line test tells us if a graph is a function itself. Horizontal line test will tell us if it has an inverse function. Now, if it is a function, so if, let's see, how do I want to say it? If, let's say, a graph is a function, and it has an inverse function, it is 1, 2, 1. So this term 1 to 1 means this. For each x, there is exactly one y, and for each y, there is exactly one x. So if we look at this one, each x, because we can draw a vertical line anywhere, has one y, because it only touches one, and each y, so if I go horizontally, each y has exactly one x. So for each x, there is a y, and for each y, there is one x. So we have one x goes to one y, and one y goes to one x. That's why I call it 1 to 1. Now, this one, each x goes to exactly one y, but each y does not go to one x, because this one is not 1 to 1.
So it only applies to graphs that only have absolute minimum and maximums. They don't have any relative differences.
What are they?
Oh, the one-to-one.
Okay, yeah. It cannot be 1 to 1 if it has an absolute max or an absolute minimum, unless we're only talking part of a graph. So, for example, would this graph? So y equals square root of x. What does this graph look like? Okay. Does this have an absolute minimum? Yeah, it's right there. It goes to 0, right? Is this graph 1 to 1? So does it pass the vertical line test? Does it pass the horizontal line test? Yeah, so this one would be an exception to that. So basically graphs that have an end point would be exceptions. But otherwise, you're right. If it has an absolute maximum then and it doesn't have an end point, then yes, you would be right. Is that all? Okay. Now, you're going to be asked to find the inverses. Let me give you a 4-step process. So start with something simple. F of x equals x squared plus 4, where x is greater than or equal to 0. What is this graph going to look like? It won't be a full parabola, right? Why not? Because I put this restriction on it, right? So it's going to start at 0, because we can plug 0, but actually 0, 4, because we're up 4. And which side is it going to be on? Okay, right, y. Yeah, because we're saying x can't be negative, so we know it's going to do this part of the graph. Now, I'm going to draw the other part. If I didn't put that restriction, we'd have this whole graph, right? However, I put this restriction on. Why do you think I did that? Yeah, because otherwise I wouldn't be able to get an inverse function. I could still find an inverse, but the inverse would be a relation instead of a function. So, the 4 steps. S, 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 S. So, first step. Substitute. And what I mean by that is change f of x into y. This is a convenience thing. It makes it easier to do all the other parts with. So this step is not necessarily necessary. So all I did is change this and say y equals x squared plus 4. Next one, swap. This is the key step. If you don't do this step, then the whole thing falls apart. So this is actually the only one that is 100% necessary. What it means is swap x and y. So I'm going to get x equals y squared plus 4. Now remember, my original said x is greater than or equal to 0. So I'm going to carry that down. Now I'm going to say y is greater than or equal to 0. Is everybody with me? You understand what it is? Okay. So the next thing, solve. And it says for y. How do we solve this for y? Okay, subtract 4. We have x minus 4 equals y squared. Square root it. So we get y equals the plus or minus square root x minus 4. Now, we've got a restriction that says y is greater than or equal to 0. What can I do with this to make this simpler? Yeah, no, we don't care about the plus one, right? We want to actually change it to y is just equal to square root x minus 4. Because of this part right here. This says we can only think about the positive one. We don't want the negative one.
So if it was different,
If we didn't have this part, then yes, we couldn't make this change. So now we've got our solve. And then the last one is a swap. Y to S inverse. So we get Y, or not Y, S inverse of X is equal to square root X minus 4.
What about the y squared?
Okay, now because we already took care of that in this step, we don't need that anymore. Because this already is greater than or equal to 0. And what is the parent graph for this? Square root of X, how is it shifted? To the right 4 units, so we're already positive. So now, in your calculator, graph both of these. Graph x squared plus 4 and square root of x minus 4. Yeah.
What does it look like if y is greater than or equal to 2?
1 is greater than or equal to negative 2?
Yeah, what would you
Well, this wouldn't change actually.
want?
Because this is already greater than 0. So if I just put negative 2, it doesn't actually add anything to it. Now, a complication you have in your calculator. I don't know of any way to put this easily into your calculator, into there. There is a way of doing it, but for the most part, ignore it. So we're going to have x squared plus 4. So x squared plus 4. And the square root of x minus 4. Let's see. Remember, when we look at this first one, we are only looking at part of it, right? Which part were we wanting? We're only caring about this side. What's the connection between these two? Is there any relation between them? Yeah?
Isn't it like flipped around, like, I don't know how to,
Okay. Flipped over something, yes. So you're on the right track.
it's like the same thing with the,
Now I'm gonna change something up here to make it look probably more clear. I'm gonna do a zoom square. And I'm gonna change it and look from actually 0 to say 20 and maybe 0 to 15, and then change it to square. So only look at this part and only look at this part. Now I'm going to add one more part on here. One more graph. So this is a reflection across this line. So y equals x. So this point right here goes directly across there, corresponds to that one there. Now, we could actually go back here and say, because of this, that's happening because of this swap right here. Remember, we said x equals y, swap it across the line. That's what this action is doing. It's swapping across the line x equals y, or y equals x. So, I want you to do this one, see if you can do it. So, say f of x equals x minus 4 over 3. Find the inverse. So what did you get? Okay. And let's look at what is the connection between these two values? What were we doing with the 3 before? Division. What did it change to? Multiplication. What was it doing here? Subtraction, what did it change to? Addition. And let's go back to look at this one. We had a addition here. What did it change to? Subtraction. We had an squaring. What did it change to? What is the relation between each one of these operations? These are inverse operations. Adding and subtracting are inverse operations. Multiplying and dividing, inverse operations. Squaring and square rooting, inverse operations. So when you're finding the inverse of a function, what do you see the pattern in this? We're always getting inverse operations. What would the inverse of cubing be? Cube rooting, or third rooting. How about this? Anybody know what's the inverse of 2 to the s? Logarithm. Do you guys remember logarithms from Algebra 2? Somewhat? Okay. Oh, we'll be looking at it with more details this year. But each one of these operations we have has an inverse. And that's what we use to get the inverse. Now, one of the uses of inverse is f and g are inverses if and only if. Everybody's seen that before, right? IFS. If and only if. Probably thought in geometry, it may be algebra 2. F of g of x is equal to g of f of x, which is equal to x. The two functions are inverses if and only if, when you plug them into each other, they get x as an answer. So we had x squared minus 4, and we said the inverse was square root of x squared plus 4. Is that right? Or did I do the inverse? Okay, x squared plus 4 was original, and we had x minus 4 in here. Okay. So if I take this one and plug it in here, it's f of f inverse of x. I'm going to have square root x minus 4 squared plus 4. What do I get when I square that? So I have x minus 4 plus 4, which is x. And I could do the reverse as well. I could do square root of x squared minus 4, or plus 4, minus 4 in here. What do I get? 4 cancel x. And we could apply the same thing to this one. If I plug 3x minus 4 up here, I have 3x minus 4, or plus 4, minus 4 all over 3. So cancel the 4s, and 3x over x over 3. So this is one way of telling that if it says verify that these two things are functions, or inverses, sorry, they verify these are inverses, one way of doing it is doing this f of g of x and g of f of x, and showing that either way you get this x. Now, can you think of any function that is its own inverse? There are a few. In fact, there's an infinite number of them, but can you think of any of them? Okay, what did you say? Y equals x. So what's going to happen if I swap x and y in this? Is this different? No, therefore, this function is its own inverse. Make sense? How about another one?